Hello and welcome to another episode of Math with Martinez. We are continuing our discussion in this unit on equations and inequalities. And in this video, we are looking to solve absolute value equations. So I want to begin with a bit of a warm-up. Let's look at this first example here together. It says if the absolute value of x equals 7, what are the possible values of x? What are the possible values of x that when you take the absolute value of them are 7? Well, ladies and gentlemen, we're asking ourselves when we're talking about the absolute value of some number, we're saying what value has a distance from 0 of 7? What number has a distance from 0 of 7? And so, of course, 7 is one of those numbers, but that is not the only value. That is not the only value because we also have its counterpart, -7. Both of those values, when you take the absolute value of them, are 7. So those would be the values of x that could work. Now, looking at question number 2. If the absolute value of x is equal to -4, what are the possible values of x? What are the possible values of x so that when you take their absolute value, it is equal to -4? How can you have a number whose distance is -4 from 0? Well, ladies and gentlemen, there are none. There are none because x cannot be -4 away from 0. On your number line. So these are some big ideas that we're wanting to keep in mind, that there are, if you're taking the absolute value of a quantity x, there really are two possible values of x to get this output, unless they are putting up an equation where you're coming to a point where the absolute value is a negative quantity. Well, that, ladies and gentlemen, cannot happen. And that might be something that we want to really highlight and be aware of for the future. So, what are these steps to solving absolute value equations? The first step is to isolate your absolute value equation. That's going to be the very first thing that you need to do. Isolate, oops, I want this color. Hold on, sorry. We want to isolate the absolute value equation. Then you need to create your two cases. You need to set your inside equation equal to both. Here we go. We need to set it equal to both the positive and the negative value of the number on the opposite side, just like we witnessed here at the start. Then we'll solve both of our equations and check for our extraneous solutions. Say what again? Extraneous solutions? What in the world does that mean? Let's go ahead and define that now. Extraneous solutions are solutions that do not work in the original equation. They are going to make it false. they're going to make it false when we do the checking. So let's begin this process, you guys. We're going to begin with this example 3 here. Let's go ahead and check. Let's go ahead and follow these steps that we saw just above, and not forgetting to check for those extraneous solutions at the end. Here we go. Step number 1 is to isolate our absolute value equation. Well, in this case here, my absolute value equation is all by itself. Contrast that here with this problem of 5. You see how there's something that is added to the absolute value? Number 3, step number 1 is actually already done. So then we move on to step number 2, which is to create our 2 cases. We're going to create the case where what we have is a positive output, where you have that x minus 9 is in that positive direction, like on the positive side, but then also you need to say that x minus 9 could have been, technically, that quantity could have been a negative 5. The difference of x and 9 could have been a negative 5, but because we're taking the absolute value, it is going to give us a positive quantity at the end. So with that, now let's go ahead and solve both of our equations. To solve this equation that is in green, we need to go ahead and get x by itself. That would be done by just adding 9 on both sides of our equation. We now have a 0 pair and x is isolated. X is equal to 14. And similarly, we would add 9 on both sides. 0 pair there on the left, so we have x equals a negative 5 plus a 9 is a 4. Those are my solutions. Now let's check and make sure that they work. When I take and substitute that 14 back in, if I say 14 instead of x and then minus 9, what is 14 minus 9? What is 14 minus 9? That's going to be 5. And when you take the square root of 5, it is in fact 5. It works. What about for this other one? When I take and substitute 4, right? I'm taking this 4 and plugging it in for x. What is that? 4 minus 9, that's going to be the absolute value of negative 5, and the absolute value of negative 5 is 5. So we are good to go. All right, ladies and gentlemen, let's look at this problem 5 together. Problem 5, like I already mentioned, is going to need us to take care of step number 1, which is that isolating of our absolute value equation. We'll do that by going ahead and subtracting, let me get my color, subtracting 17 on each side. After I subtract that 17 on each side, I will then have that the absolute value of y minus 1 is equal to, what is the difference of 23 and 17? That is 6. All right, now we set up our two cases, set the inside equal to both the positive and the negative values of the number on the opposite side of our equation. So what does that look like? Well, I would have my one case, which is that y minus 1 equals 6, and also that y minus 1 equals a negative 6. All right, so let's go ahead and finish off those equations. What are they? When I add 1 on each side here to solve this equation for y, my y equals 7. And for the other, if I go ahead and add 1 on each side, my y equals a negative 5. Now we need to go back and check our work. I'm going to go ahead and do this in this little bubble here. Oops. Sorry, let me do like that. Let's get this color here. Let's go ahead and check. I'm going to do that here in this box. All right, so if you take and you substitute in 7 in place of the y, so that's going to be 7 minus the 1, and then you add 17, what is that going to give you? You're going to have, that's going to be 6, that's going to be equal to 6, and when you take the absolute value of 6, that's once again 6, and 6 plus 17 is in fact 23. So that works. That's what we wanted. If you try the other value, the negative 5, you take the absolute value of negative 5 minus 1. That's going to be a negative 6, but when you take the absolute value of a negative 6, it is 6. And 6 plus 17 is in fact 23. So those are both my solutions. Last problem here, you guys, that we are going to do in this video. We're looking at problem 7. Remember our steps. Step number 1 is to isolate the absolute value expression. Right now, I've got a 16 and it is in front. It is in front of my absolute value symbol. It is therefore multiplying with it. So what do I need to do? What is the opposite of multiplication? I need to apply that multiplicative inverse and divide each side by 16. That will then give me my absolute value of r minus 5 equals a negative 2. And ladies and gentlemen, what does that lead us to conclude? Remember, at the very start, we said that if you have this kind of scenario where your absolute value is equal to some negative quantity, we're saying here that the absolute value of something is equal to negative 2. Well, that cannot happen, ladies and gentlemen. This is a problem that has no solution. And we are done. Again, why is that? Why do we have no solution? Because you cannot take the absolute value of a quantity and it be a negative distance. Ladies and gentlemen, that is all for our video today. If you had any questions, please take a moment to share those now. And until next time, stay fired up.